Hello, and welcome to Two Dancing Clams. This is a Blender 3.4 tutorial showing how to construct liquid-filled procedural glass decanters using geometry nodes. This project was born out of a need to create an entire shop, and modeling each bottle independently was way too tedious. Controls are provided to create any shaped decanter with rounded or square sides, or a combination of the two. The tutorial also shows how to create simple textures for the glass and the liquid to control the color and the index of refraction. The square sides are created by a maximum, and that can be set to anything you want, or most of the time for a rounded glass decanter it's removed. The one thing I spend a lot of time on is allowing the shape of the glass to be controlled from these nodes. So there are 6 values that correspond to 6 locations along the curve, which, because the edge is defined by a NURBS curve, is actually plenty. You could add more. The more you add, the more control you get, but also the more tedious it is to get to exactly the right shape. Like if you had 100 controls here, you'd have to move 100 little sliders and get each one just perfect. So I think I tried a few different things. 4 didn't give me enough variety. When you get to 8 and 10 sliders, it gets to be too much. So I thought 6 was about the sweet spot. And it allowed me to model pretty much every decanter I could find an image of on the internet. 2 quick things before starting. 1, I'm going to make extensive use of node wranglers, so please turn that on in the preferences before starting. Also, if you're having trouble reading the text in the node groups, that usually means that YouTube is displaying the video to you at something less than the resolution I uploaded it at. You can fix this by going into the YouTube settings and switching it from auto to 1080p. First thing to do is to create your geometry nodes. Drag this up and add some geometry nodes. I'm going to use my imagination and call this glass decanter. We will not need the cube. The basic shape of this is going to be a line, a curved line, that we'll do curve to mesh on and essentially create a surface by rotating the curved line around a circle. And we want this to go out along the negative y-axis, just 1 meter. The reason for this is if it goes out on the positive y-axis, then when we form the surface, it'll be pointing in the wrong direction. It's just one of the advantages of being able to look into the future. And the other thing is we'll do, as we shape the curve, we'll shape it along the negative x-axis, so that way the detail goes in, as opposed to if we did the positive y-axis, the detail will go out and our jar wouldn't have a bottom. You'll see that as we go along. I want to resample the curve into 8 points. The reason for this is we want to control 6 of them. The last one will be the center of the bottom of the decanter, and the one next to it will be about halfway over. This is because NURBS tend to form very smooth lines, and it takes 2 to get anything like a reasonable flat bottom on the bottom of our decanter. And now we have a line. I'm going to give this a name while I'm thinking about it. Speaking of things I'm going to do while I'm thinking about it, I'm going to set the render engine. Go to the render properties. I want cycles. Switch it over to GPU for speed. And this is way too many samples. 128 is fine. Just want to do that because I never remember, and then something looks weird later and it takes me 5 minutes to figure it out. Okay, now let's turn this into a surface. Use a curve to mesh. This will be our profile curve. That's it. No bottom yet, but we'll take care of that. We'll take care of that actually last. First, I want to put in the points that allow us to control the shape of this curve. I'm going to add 6 of these. These values will control the shape of this curve, starting at the top, moving to the bottom, with the final 2 reserved for forming the bottom. 1, 2, 3, 4, 5. And let's start those all out at 0.5. Now something inside me says there might be an easier way to do this, but I have yet to discover it. I think maybe what my brain is telling me is there should be an easier way to do this, like some sort of array input into a node group. But until we get that, we're stuck with this. The other way you could do this is use a float curve inside the geometry groups, and that is the way I originally did this. But that also means anybody using this has to dig inside the node groups every time they want to change the shape of the glass, and I didn't like that. So this is just a nice compromise between utility and convenience. Let's hook up these control points so we can control the shape of the curve. First, we want to be able to control the y value based on the index of the point along the curve. So the maximum we've decided in advance will be 5. So if we divide 1 by that, we get 5 equal spaces between our 6 curve points. We also need a value to indicate which index this is. We'll change this shortly, but this is just a placeholder for now. So if we multiply the space between the y values by the index, we get the point. We get the y value of the place where this particular point should be. And we are starting at -1, which is the top, and then we'll work our way towards 0. And this is the y value in the final coordinate, the xyz. Now let's do the x. We'll want an arbitrary value. This is what the user is going to give us. Start this at 0.5. I'll throw this away in just a second, but I just need a placeholder for now. This will also start along the negative axis and work its way towards 0. And this will form the basis of a set position. But we only want this to control one of the points. So we'll take our index and compare it to the actual index of the point and only do the set position if this is true. So now you can see we're controlling index number 0. And we indeed control it. And the reason I went to do it this way is because I want to create a node group because we want 6 copies of this. Control G. We want 2 variables. We want a floating point value where the user can pick the x value, in other words, the shape of the curve at a particular point. And we want index to be a integer. So the index will be used everywhere we use this. Don't need that anymore. And the x value, just one place. So for our first value, we're going to have an index of 0, and then we're going to hook up this curve value here to this. So if I drag this into space and type group input, I can hook it up to curve 0. Now, this value controls this value. Nice. I'm going to whip through the others real fast. It's a little tedious, but this is the only way I know how to do it. And we have 2 more points. And like I said in the intro, we want 2 points to define a flat bottom for a NURBS curve. So 2 more set positions, but these are going to be special. Stick that back at 0.5 while I'm talking about it. So the last one is going to be the middle bottom. Let's do that first. This will only take effect if the index is 7. And we will force this point to be -1, 0, 0 on the x-axis. And we have a bottom, and we just have one more. And I would like this one to be halfway between this and whatever value they chose for the bottom. Because I don't want under any circumstance for the curve to flare out, so I want it to flare in. And about halfway between the point they specified and 0 is about right. So this will be index 6. Grab a copy of this. Just like the other values, this will be bounded at -1 and move up towards 0. Actually, I want it divided by 2 and add it to -1. So I'll change this to a multiply add. And we have a bottom. And we have the ability to control a curve. Now, right now, it looks a little bit pointy because it's a poly curve. That's more like it. Could use a Bezier, but then we'd have to deal with the control points, which would be a whole lot more complexity. Admittedly, more flexibility, but NURBS is just a nice compromise for both of those. Before we go on, I'd like to give this some more decanter-like shape. So let's give it a bit of a neck with a flare out. I think that'll do it. Which is something a little nicer to look at. One of the key features of this node group is the ability to produce a wide variety of glass decanters. And one thing I've noticed is glass decanters in bottles. And one of the things I noticed is frequently the front and the back will be squared off, flattened in. And sometimes the base of the decanter will actually be a square or a rectangle, and it'll move into something more round at the top. Easiest way to accomplish that is by taking our current model and putting a maximum and minimum on the X and Y. Start with the position of each element. Separate them out. At the end, we're going to combine them back together into a set position. So the Z will go through unmodified. The X and Y will be bounded. We will adjust the X to be a certain minimum and then also a certain maximum. So we'll take a certain X value, multiply it by -1. That will be our maximum. And then we'll take that same value and we won't multiply it by -1, and that will be our minimum. And so anything that remains will get squashed inside that box. Shift D to do the same thing with Y. Now, what will the minimum be? We'll get that from a user value. I call those clamp X and clamp Y. By default, I'd like the number to be so big it won't apply to the default model, just so it's something that won't be turned on unless the user wants it to be. So if we drag that value out into space and then type in clamp, we get to directly go to our group input and the value we want, which is clamp X. And so that will work for the minimum. And for the maximum, again, we'll multiply this by -1. And we'll give it a fitting name. And we'll do the same thing over here. Drag this out into space and type clamp and select Y. Now nothing changes because these are big, but when we make them small, it pushes in the side like that, or the front. Nice. So this can be used to give a much wider variety of shapes than a rotated line can do. Now to make this into a proper container, it needs to be 3D, and currently it's just a 2D surface. So what I want to do is make a copy of this and then create a bridge between the two to make it into a single 3D object. So I'm going to run 1/2 through a flip faces, and this will be the interior face. Now I don't really care which way the normals are going, but what I do want is the surface normals to be pointed out from the glass object. So by doing this, the normals on the inside of the container will be facing in, and the normals on the outside of the container will be facing out. This is the only way to get the glass shader to work properly. If I didn't do this, you would actually get a 3D container, and it would look great, until you rendered it. And then the interior reflections in the glass would do crazy things. For one thing, they completely obscure the inside of the glass, so you won't see your liquid at all. This branch will be the interior. Now I need one for the exterior. For that, I'm going to do a store named attribute. I'm going to do this for two reasons. One, I want to mark the topmost vertices in the object to extrude later. That will form the lip of the decanter and also bridge the inside and the outside. Also, when I do the scaling up of the interior to the outerior, the bottom of the decanter will move down a little bit, the sides will move out, and the top will move up. That's just the way scaling works. But I want the top to be flat. So if I mark those places, I can push them back to flat to have the interior match the exterior, and that way the lip will be horizontal. This will be a Boolean. Grab the position of each vertex. And to do this test, we want just the Z. And I know that the top of my container will be at Z equals 1, always. So anything that is roughly equal to 1 is the top. Now let's go ahead and scale this out a bit. I'm going to do a set position. We're going to move each position outwards along the face normal. Now, I could move them inwards just as easily to create a thickness, but on the inside of the bottle is going to be the liquid. And it's easiest if I start with the inside surface of the glass, I expand it to make the outside surface of the glass, and also I contract it just a little bit to make the liquid, then everything lines up nicely. So we're going to move this out. Drag that out into space and type group input. And we want this new value to describe the thickness, and a float is fine. And you can see we get a little bit of thickness. Love it. I think 0.013 is fine for this. Now, I said before we want to make the top inside Z the same as the top outside Z. Let's do that now. So in this case, the outside Z needs to move up just a little bit. But we only want to use the vertices we've previously marked as the top. I like the way Blender remembers which attributes you have floating around your environment. It makes it really easy. So that's top edge. So we'll take the X and Y of these labeled vertices unmodified, and the Z will force to be 1. And you can see it scooches up just a little bit, which is great. Now I want to create a new surface to join these two. So again, I'm going to take the points along the top edge of the inner surface and extrude them outwards. Once again, we're dealing with just the top edge, and this will be an extrude operation. We only want the top edges, and we only want the top edges. Take a math node and multiply. This is going to be a scale, and it's going to be based on the thickness. The thickness of the glass, that is. And by making it -1, we make it go inwards rather than outwards to join the outer and the inner sections of the glass. Now, there's one nicety I'd like to add here, and this only really matters in some of the more extreme cases, but just to make sure that the extrusion is perfectly level. So I'll take the normal, remove the Z value with multiplication, normalize to push it out so that the length of the vector is 1. And there we have it. It actually makes a little bit of a difference in this case too, I'm surprised. I guess that is kind of more of a rake on the rim than I usually have. Anyway, this will make all the shapes of the decanter near the rim, regardless of how extreme it is, to within certain limits, join up properly. And of course, we want to actually have the outside be part of this party. So let's put that back into our joint geometry. And then join it all up into one big happy hole with merge by distance. And while I'm thinking about it, let me do one other quick thing here. Let's go down to material. Add a procedural texture for the glass. And a procedural texture for the liquid. And set that here. We won't do the texture right now, but I just want to remember that it needs to be done. Now there's just one more geometry task we need to do before finishing up with the textures. And that is to create the liquid. So the liquid is going to be just another copy of this thing we created earlier. We're using one copy of it for the exterior, one copy of it for the interior, and now yet another copy for the liquid. Now, the liquid is going to go from the bottom of the decanter up some percentage of the way. And I want this to be adjustable because it creates a huge difference in look. And it's one of the ways to give a variety of looks to a series of these decanters you're going to create. I'm going to create a Boolean called flatten. And these mark all of the vertices above where we want the top of the liquid to be. Take the position, get the Z. And if this is greater than or equal to our liquid level, then we want to push it back down. And what is our liquid level? We'll let the user decide. Create a new input variable. Set that at 0.5. Now this was actually one of the inspirations to do this in geometry nodes rather than sculpting, because one of the problems I kept having when I was sculpting these decanters was I would start off with a basic shape and I'd use part of it for the vase and part of it for the liquid, and each would have a subdivision surface. The problem is when I arbitrarily lowered the liquid level, or cropped off that polygon, the subdivision surface would cause the top of the liquid to curve in at a different rate than the glass edges of the decanter. And sometimes the liquid would curve out more and sometimes it would curve in more. It would have to do with how close I had cut it to the nearest vertex. And that was a problem. And you could bring it up and fiddle with it and make it look right. But it just kind of frustrated me that there was no precise way to make the curve of the liquid match the curve of the vase. In geometry nodes, there is. So what we're going to do is we're going to put the top of the liquid at the nearest vertex. This will keep the vertices in the liquid at the same levels as the vertices in the decanter, and the shapes will match. That doesn't make sense. It will in a second. So just for a minute, I'm going to do Control-Shift just so we see the liquid level. And if these vertices are at or above the top of the liquid, we're going to push them back to the origin. So that creates our lovely liquid level. Now this is terrible because now we have essentially a funnel in the middle of our liquid. So let's fix that. So this determines the shape of the liquid. And what I want to do is I want to find out where the top of this is so I can take all those vertices I just pushed to the origin and just move them back up to the top of the liquid. Use a bounding box. This will, by taking the maximum of the bounding box and multiplying it by z equals 1, we get the top of the box. We'll need a set position. We'll use, again, the vertices we've marked that were above the original level of the liquid. We'll move them to the top of the box. We'll do a merge by distance to make all those points that just got moved to the middle one single point. And we'll scale by 0.99 just to pull it away from the glass a little bit. It helps with the way it looks when it's finally rendered. Don't need that. We do want to set material, and that will be our liquid. One more join. And that should be the finished shape. Now all we need is some textures to make it all work. First thing I want to remember to do is turn the viewport shading to rendered so we can actually see the glass. I want to create a plane because glass objects in an empty environment look boring. Scale that up by 20. Now I want to be able to control the color of the liquid and the index of refraction of the liquid from the user interface. Color, because we want different colors liquid. Index of refraction, because the index of refraction controls how light bounces around inside a material. If the glass and the liquid have the same index of refraction, it doesn't look like a decanter. It looks like a bottle with two different colors of glass. So we want them to be different. And what I've discovered is I'm never exactly sure what values will look good in a scene. So it's handy to have the liquid index of refraction available as a slider so you can just change it to whatever looks good. So we want those to come from this environment. So I'm going to create two new variables. First one is a float. I'm going to call it liquid index of refraction, and its value is going to start at 1. Second one's going to be liquid color, and I'm going to start off as a red. Now we need to get the values from here into the shader editor. We can do that with a star named attribute. Shift D to get us another one. So we'll grab this liquid IOR from the environment and plug it into the star named attribute. It is not important that these two have the same name. It is important that whatever name you put in here is what gets used in the shader editor. And we'll do the same thing for the color. Okay, now our environment's set up. Let's go to the shader. I'm going to do the glass first, which is in slot 1. A dot to fit our view. A little annoyed that that is still necessary, but whatever. So to make a glass-like substance, we want to do transmission to 1 and the roughness to 0. Actually, these don't have to be exactly 1, exactly 0. Again, something you can play with to make your scene look right. Now let's go to the liquid. Same thing, transmission up, roughness down. Now let's use the environment variables we set up. We fetched them with attribute. Use the same names we used inside the geometry nodes. And voila. It adjusts up and down just like we want it to. Zoom in a little bit. Cool. Now let's grab the index of refraction. And this will come from the other star named attribute we did. Hook up the factor. So now this is the effect I was talking about. So you can play with this. And you can see how the effect changes rather dramatically. Like if it gets too low, the liquid kind of disappears inside the glass. Anyway, so 1-ish is good. But again, it's something you want to have control over. There we have our final decanter. This made creating my wine shop just so much easier and faster. And the takeaways from this are, it's really a fairly simple thing, but using a fixed array of values to control the shape of a smooth object is something I'll definitely be coming back to. You could use this to set like the branches at the level of a tree. So you could, if you had a tree generator, you could use this technique to shape the outer edge of a tree. You could use it to define the contour of a branch or a trunk, a landscape. I think I'll be coming back to this quite a bit. The project file for this is up on Gumroad. Just follow the link below. And thank you so much for watching.